Hello friends, welcome to Suresh Aggarwal's Mathematics Shortcuts. A very important video for all students who are studying in class 7th, 8th, 9th, 10th. And this concept which I am going to take up is used in so many competitive exams. One of the most unavoidable concepts as this is asked in most of the quantitative aptitude exams. This is the concept of converting a non-terminating recurring decimal in the form of p by q. So we all know that when there is a non-terminating recurring decimal like 10.333333 and goes on and on, non-terminating recurring, that means something is reoccurring, okay, we can write it in the form of p by q. That means it is rational. So how do we convert that, and is there a short trick to understand that and to write it directly without using the traditional approach of assuming the number as x and then having a multiplier 10, 100, 1000 and so on? So many mistakes in this concept, done by the students at class 8, 9, 10th level. So I thought, let us simplify decimal conversion into p by q form for all the students. This happens to be a part of chapter number 6 of our ebook of short tricks, which is conquering the decimals. And once you conquer the decimals, this is really going to be very exciting for you. So friends, let's see what is the concept behind the trick by using some of the examples. But before that, let me tell you about this ebook of short tricks, which contains 350 such smart methods. If you are a school student looking to calculate 10 times faster, or a college student looking to prepare for those placement exams which you are going to face in future, quantitative aptitude, this ebook is for you. If you want a copy of that nominal costing ebook, send me a message on WhatsApp. This is the WhatsApp number 9896369963. Once more, 9896369963. All these details are contained in the video description as well. So friends, is there a short trick to convert non-terminating recurring decimals in the form of p by q? Yes, there is. So let's first understand by taking a simple example of 0.5 bar. We all know 0.5 bar is like 0.55555 and it keeps on repeating. Non-terminating recurring. Okay. So the first thing we have to understand here is, after decimal we have the bar starting, right? That means after decimal everything is repeating. Like here 0.69 bar. What does it mean? It means that this is 0.69696969, both of them, they keep on repeating together. This is what we mean by non-terminating recurring decimal. So in both the questions, after decimal there is nothing which is not repeating. So everything is under the bar, right? After decimal. So this is one particular case where the question becomes very easy to handle and you can actually write the answer directly without having to do anything. I'll tell you how. When this situation arises, just forget the bar first. So you have a single number 0.5, right? So 0.5 bar will become equal to 0.5, which is just 5, and divided by how many digits are under the bar? One digit is under the bar. So write 19 here. Okay? And surprisingly, this is the answer for the question. Likewise, if you see here 0.69 bar, if you forget the bar and the decimal, this is 0.69, which is just 69. And what do you write in the denominator? How many digits are under the bar? 2 digits, right? So write 2 nines. 69 by 99. Now there is a common factor between 69 and 99, so you have to reduce it. Like there is a common factor 3, 23 times and 33 times. Now try picking up the calculator. 23 divided by 33. Do it on the calculator and check. 0.69696969 will be the answer. And this is the first short method of finding the rational number equivalent of non-terminating recurring decimals where after decimal everything is repeating. Okay. Now this is the first thing. So how much time you are going to take to solve this? 3 seconds? 5 seconds? Even 10 seconds? That will be an amazing speed. Okay. Let's see this one. Here we have something which is not repeating. See, 42.73 bar means this is 42.7 is not repeating. Only the number under the bar is repeating. So 3, 3, 3, 3, 3, 3 is repeating. Right? Now I want to find the decimal, the rational number equivalent of this decimal. See what I do now. First I will forget the decimal and the bar. So we have the number 4273. But this time there is a digit after decimal which is not repeating. So now from 42.73 bar you will forget the decimal and you will forget the number under the bar. So what are you left with? 427, right? Just subtract 427 from this, and in the denominator, now this is one more concept which you need to remember. Here you have one digit under the bar, so 19, and one digit not under the bar. So the number of digits not under the bar is equal to the number of zeros you will put with the nines. One digit under the bar 19, one digit not under the bar 10. This is the next important step. And now you will have the answer in the next step. 4273 minus 427 gives you 3846, and divide that by 90. Reduce it to the lowest form, that is very important. Divide by 2, so you get 1923 divided by 45, and I think both of them are divisible by 3. 3 6 are 18, so 12 means 4 and a 1 and 15. Now I don't think they are divisible by 3 or 5, right? So 641 by 15 is the answer for the question. Now pick up the calculators, friends, and keep on checking and see the difference in the rule. That's important. Okay, let's apply it here, you will understand it better. So here you have, first forget the decimal, forget the bar. You have 8, 3, 5, 6, 9. Now because something is not under the bar after decimal, you will subtract, forget the bar, that is 69, forget the decimal, 835. Okay, and in the denominator, how many nines? Because two digits are under the bar, 2 nines, one digit not under the bar, so 10. Now this is the important step. Once you get through this, rest is elementary addition, subtraction and cancelling of the common factor between numerator and denominator. So the thing which you get here after subtraction is 82734. So 82734 and divide by 990. So you can remove the common factors now. There is a common factor 2, I think, which you can eliminate. 82734 divided by 990 will become 41367 divided by 495, which will further reduce, I think 3 is a common factor, 13789 and divide that by 165. Now you can check whether there are more common factors or not, but I don't think there is any more common factor here, which gives you your final answer for the P by Q representation of this big non-terminating recurring decimal. Okay, so let's apply it to some more questions here. See, big question. First write the complete number 128361. Subtract, forget the bar and the decimal, so 1283, and upon 2 digits under the bar means 2 nines, 1 digit not under the bar means 10, and this will give me 127078, and in the denominator 990. I think this can be further reduced because 2 is a common factor, so 6, 3539 and 495, and I think this is the final answer for the question, because I don't think we have any more common factors between numerator and denominator. Now using the calculator and checking is really important. So please check it, and you need to let me know in the comments whether all these answers are correct or not. Okay. So one more. First forget the decimal and the bar. 34892, and I don't need to subtract anything here now because there is nothing after decimal which is not under the bar. So upon how many digits under the bar? 2. So 99. And 34892 upon 99 will give me my final answer here. Obviously, before decimal you have 348. So if you subtract 348, I think that will give you your final answer. So subtract 348, you get 3, 4, and then this is 4, and then 4, and then 5. And divide that by 99. There might be a common factor here which we can cancel out. Let's check. This is divisible by 3. So 4 plus 4, 8 plus 5, 13. Plus 4, 17 plus 3, 20, not divisible. 11, 3 times 33, 15 means 4, 44, no. So not divisible, so this is the final answer. See, just write the complete number, subtract, apart from the bar, you have 348, subtract that, and how many digits are under the bar? 99. No zeros here because after decimal you don't have anything not repeating. Okay. So friends, this is how you become smarter. This is how you start learning the things, and this is how you save time in the exams. So if you like this video, do share it with all the school students who are struggling in such concepts, and use them to crack MCQs. That is important. And check the timing, how much time you are taking to crack the MCQ, and are you actually benefited by these amazing short tricks. Do share this video with those friends, and do subscribe our channel Suresh Aggarwal's Mathematics Shortcuts. Along with the subscribe button, you have to hit the bell icon now. This is the bell icon. If you hit that and click all notifications, the notifications of future uploads will start coming on your mobile itself. Practice 30-40 questions, and I will wait for your comments. Is it working for you? All the best.